Welcome everyone to the 4 o'clock session of Building an Online Video Player. I'm Jeff Tapper from Digital Primates. So today we'll be talking about how we build video players, talk a little bit about the streaming landscape today, what are the various options available to us, what are the various formats, if we're going to play back on desktop, where can we play these days? And this is constantly changing. And then we'll talk a little bit about some of the off-the-shelf providers, and as you guys probably know, there are dozens and dozens of them. I'm going to talk about the 6 I see most commonly in what we do. We'll talk also about how, if you want to go ahead and build them yourself, how do we do that? How do you find the right fit for your project? Because ultimately with all these choices, there's no one right answer for everyone, so let's figure out how do you make the choice for yourself? Then a summary and some questions. As always, if you have any questions throughout, you don't need to wait for the end for questions. Just raise your hand. I'll be happy to take questions any point throughout the process. So real quick, who am I? I'm Jeff Tapper, a senior consultant at Digital Primates. At Digital Primates, we focus on building the next generation of client applications. A lot of that happens to include video applications these days. And we've built hundreds of video applications for some major providers over the years. We've done some of the most watched live broadcasts in the internet's brief history. I've been an internet application developer for just over 20 years now. I've had a chance to work on about a dozen books. So now that you know who I am, the question is, who the hell are you guys? What are you doing here? How many of you consider yourselves developers? How many of you write video applications today? How many of you want to write video applications soon? Okay, wait, if you don't want to write video applications, why are you here? Seriously, are you just killing time until they start serving beer? Whatever, you're here, I'll take you. Of those of you who do video applications, how many build your own players from the ground up? Small handful. How many work with one of the off-the-shelf players? Even more of you. Okay, cool. So, as you guys know, there are lots of different options available to us today on the internet in video, right? The number of devices that we can now play video on is astounding. And there's a big number of choices. There are lots of different codecs. There are lots of different streaming protocols. And for many years, how many of you have worked in Flash and Silverlight and other plugins? Not nearly as many as I would expect. Okay. For many years, plugins were the de facto standard for how video worked on the internet. We're moving away from that, and we're starting to see some of the browser manufacturers, Chrome in specific, is starting to remove some of their APIs that enabled some plugins. So as most of you guys know, Silverlight is no longer being supported in Chrome. Is this news to anyone? Any of you still maintaining Silverlight applications? But you know it's not on Chrome, right? You're good? Good. Okay. Excellent. Glad to hear it. And so more and more, we're starting to see people who want to stream natively in the browser. The challenge of that, of course, is that different browsers have different level of support for what you can and can't do. But the nice thing about using HTML5 and natively streaming to the browser is you can use a lot of that same code to stream to other devices as well, which is great. Protocols. There are 2 big categories of protocols that I tend to talk about. There's the real-time protocols, RTP, RTSP, RTMP, and there are the HTTP streaming protocols. And the fundamental differences of the 2, the real-time protocols effectively open a socket from the server to your client. So each connected user has a separate socket open directly to the server. Where HTTP streaming protocols, they work much like every other web page out there. The browser makes a request to the server sends back a packet of data. That packet of data happens to be a segment of video. And on the HTTP streaming protocols, the common ones you'll see these days, HLS, smooth streaming, HDS, and Dash. Nothing surprising yet? It's all excellent. The real-time protocols have one tremendous benefit. They have ultra-low latency, or they're capable of being ultra-low latency. If you want to get the most recent information to end users as rapidly as possible, your real-time protocols are your friend. If you're trying to do a live online auction, RTPs are great for you because everybody can see the same data at the same time, and it's great. Liabilities. They require a whole lot more server infrastructure, especially if you're dealing with large loads. I recently helped a major sports broadcaster deal with moving from real-time protocols over to HTTP protocols for a big soccer tournament that may have happened in South America last year, where there were millions of connected users at once. And it just wasn't efficient to require that number of connections back to a server. The HTTP protocols, again, you're far more common. Most new players you'll find are making use of these today. They're very network efficient. They're easily cacheable. The internet was built around the HTTP standards. So it makes a lot of sense. And they'll work with any web server. Ultimately, what you're doing is you're just putting some packets, some files on a web server and letting the browser request them. It makes a lot of sense. Liabilities. It requires a little bit of extra work. Your video files have to be chopped up into these discrete segments. So that's what we call packaging. And there's some packaging on the fly that can happen. It doesn't have to happen ahead of time. And also, there's additional latency that's inherent in these systems. All right, so, and just a quick walkthrough of our HTTP streaming protocols. Smooth streaming is a standard out of Microsoft. Was built originally to work with Silverlight, now works these days on Xbox, Windows 8, and a whole lot more. Has digital rights management available to it very easily from PlayReady. HDS is the HTTP Dynamic Streaming. This was Adobe's HTTP standard. Worked very well with Flash, and it had what's now called Primetime DRM, which used to be Flash Access and used to be Adobe Access, is available for it as a DRM. Interesting thing with HDS is Adobe has now effectively deprecated HDS. It still works in existing applications, but Adobe is no longer maintaining it going forward, much in the same way Microsoft is no longer focused on smooth streaming either. Both, we'll talk about in a minute what those two companies are focused on. HLS, probably the single most popular of the protocols, the HTTP streaming protocols today, is Apple's HTTP live streaming. It works well with many, many devices, and there's a number of different DRMs available for you depending on where you're trying to play it back. And last but not least, the protocol I'm most excited about is MPEG-DASH. DASH stands for Dynamic Adaptive Streaming over HTTP. It's an open standard. You may have noticed the other three I mentioned, they're all owned by one company. They are closed standards. DASH is an open standard that was formed by a consortium of several different companies, including Microsoft and Adobe and Apple, and Google and several others, who decided to find what's our best practices. What have we learned? We've all built our own standards. What have we learned from it? How can we do it better? How can we make things more interoperable? And that's what I love best about MPEG-DASH, is it's truly open. The nice thing today is that DASH is starting to work on many devices. You'll find connected TVs, the HBB TV specification is actually based all around MPEG-DASH. Anyone familiar with HBB TV 1.5? It's a big European standard. Works in a lot of other places as well. It's DRM agnostic. You can use any DRM with it. And it's an extremely flexible format. If you've heard other talks of mine, it is almost flexible to a fault, but we can talk about that over a beer if you want more information on that. So what's most interesting is that Adobe and Microsoft are now firmly behind MPEG-DASH. While they had their own streaming formats prior, now you'll find that with their new technologies, almost everything they do, they're focusing on DASH and HLS to support the legacy and the other ones that won't support DASH yet. So if you want to deploy to a browser today, there are three fundamental options. There is Silverlight, there is Flash, and there is HTML5. And in terms of streaming, with HTML5, taking a step back, are you guys familiar how HTML5 works? There's a video tag that was introduced. That video tag fundamentally would work if you simply specify a URL of a video file. It would download that file and play it back for you as it downloads it. It had challenges for streaming. Apple actually wrote their own specific extensions into their browsers so that you could specify the manifest URL for an HLS stream, and it would do all of the work. You wouldn't know what was happening behind the scenes, but it would just start playing that video for you. Ultimately, the W3C, the standards board behind most internet standards, came up with what is referred to as media source extensions, or which I abbreviate here as MSE. And what MSE is it's excuse me, it's effectively an API for that video tag. It allows us to hand a little bit of video at a time to that video tag. So instead of specifying just one file, we can build a streaming application around that video tag. And we'll dig into more detail on that. EME is the DRM side of this. EME stands for Encrypted Media Extensions. It's another open standard that, in theory, is browser neutral and agnostic for the various DRM companies. Talk to me over a beer. We'll talk about the practice and the theory and where they're not quite the same. But effectively, this is what allows companies like Netflix and Hulu to stream to HTML and not worry about people stealing their content. There's other companies that use it as well, but those are the two biggest names that I can. So, as mentioned, Silverlight was once a huge dominant player, rapidly losing market share, mostly because Microsoft has said, never mind. It was a good idea for its day, but we don't need it anymore. No longer support it. It relies on NSAPI, which are those deprecated APIs in Chrome. So it was once great, but not so prominent today. Flash is still the dominant player in browser-based streaming today. It natively supports RTMP and HDS, and it relies on the PAPIs, which are not deprecated in the browsers, so it will continue to work for the foreseeable future. Even last week, Microsoft made more announcements about their next generation browser. You guys are aware that Project Spartan, actually it's got a new name again, and I've forgotten what the new name is this week. Project Spartan, they're going to discontinue the Internet Explorer line and build a brand new set of browsers from the ground up. Microsoft had a conference, I think it was Build or something. Yeah. Ignite. Ignite was last week, wasn't it?
Edge.
Build and Ignite.
What's the name?
Edge.
Edge, thank you, that's the one. Microsoft Edge is that new browser. There's still going to be the PAPIs in Edge, or so they announced last week. So Flash will continue to be viable into the future. It remains strong, but we're seeing less of it only in that HTML5 as a streaming platform is growing in dominance. So it's Flash still very viable, important to know about. And last but not least, of course, is HTML5. It's expected to be the platform of the future. There's no plugins. As I mentioned, there's native support for progressive download, and with media source extensions and encrypted media extensions, we can support streaming to many browsers today. And just a quick little chart to sort of show you of the major browsers, what's available. So media source extensions fully available in Chrome, in Internet Explorer 10 and above on Windows 8, in Safari, but only on Mac OS, not currently Safari on iOS. And so it's not yet available in Firefox, but all indication it is available in some of their nightly builds. They're actively working on it. It should be available soon. I can't be more specific, only in that I've been told it should be available soon for about 10 straight months now. So, but I'm told soon's getting closer. So that's encouraging. They all support H.264. You guys probably know last year Cisco paid for licensing for all the browsers to have H.264 decoders. VP8 and VP9 you'll find in Chrome and Firefox, not in the others. Native HLS support for Safari on Mac and iOS, not for Safari on Windows. And Dash support is available for anybody that has media source extensions. And as I mentioned, what media source extensions are all about, they're currently a candidate recommendation to the HTML5 working group, which is effectively, they are an accepted standard. But they're not universally in the browsers yet, as you saw on that last slide. So what I'm going to talk about briefly now are some of the off-the-shelf providers. And there are far more than I could possibly give time to, but at Digital Primates, we're a consultancy. We help a lot of different clients build a lot of different projects. These are the 6 that I encounter most often, and that's why I chose these 6, not for any other particular reason. So there's Adobe Primetime, Video.js, Dash.js, JW Player, Kaltura, and Ooyala. All right, so, and these 6 cover a wide variety of use cases. went through these purely alphabetically here, so Adobe's PrimeTime, being the first one, is purely targeted at the ultra high end of the market. They're not interested in streaming the local town council. They really have no interest in that whatsoever. They want the major networks. They have, and they're priced accordingly. They're a premium video provider targeting top programmers. They have support for virtually every platform. They've got a set of SDKs, of course, that run in Flash, but they also have iOS, Android, Roku, Fire TV, Xbox, and whoever else you might be able to think of. They have platforms. They've got support for everything. Currently, they only support HLS and Dash. They are only supporting HLS and Dash, even though Flash itself natively supports HDS and RTMP. PrimeTime does not, making it really clear where Adobe's priorities are on their own former standards. RTMP was also one of Adobe's standards. PrimeTime includes many, many built-in high-end features, ad insertion and decisioning, authentication, DRM, analytics, and lots more. Currently, they're on the desktop. It works in Flash. They're going to have an HTML5 version out this summer. And it's intended as a commercial business-to-business product. It's not free. It's not open source. It's not intended for everyone. It's going after a very small market, which happens to be the top of the top. And it's a wonderful product. I build lots of PrimeTime applications for our clients. I love it, but it is decidedly not free. Next, alphabetically, Video.js by Brightcove. This one is decidedly free. It's an unrestricted open source license. It's released under the Apache 2.0 license. It's a very nice player. It's built around HTML5 first. It will fall back to Flash if the browser doesn't support the HTML5 playback. It's got support for most of the modern protocols that we would care about. It's got a very active open source community. You can find them on GitHub. Full disclosure, myself and my company are active contributors to this project. So I definitely like Video.js. I spend not only time for my clients on it, we spend our free time working on it because we like this as well. And they have a plugin model where you can add in support for DRM or advertising or analytics as needed. And they basically just get mixed in, and there are additional pieces of JavaScript that you include for your project. It's fully free. Anyone can use it anytime they want. Of course, it is owned by Brightcove, which has a whole video management solution, which does lots of other things as well. And they, of course, would love you to use that as well. Dash.js. Anyone heard of Dash.js? Only a small handful of you. Dash.js is a much smaller open source project. I was the initial architect of Dash.js. We came up with this as the Dash Industry Forum is a consortium of companies that got together to help promote interoperability within Dash. They needed a reference player. This was right around the same time that the media source extensions started becoming available. So we architected and built the initial versions of Dash.js. Dash.js has actually since grown quite a bit. We now have, I want to say, something like 20 different companies, including Microsoft and Google and Adobe and Brightcove and many others who are active contributors to this project. It's fully open source. It's under the BSD3 license, so anyone can use it. And the reality is many of the other players I'm talking about today are using Dash.js for the HTML Dash support in their players today. So again, I'm a big fan of open source and open standards, so we're also big contributors to Dash.js as well. The JW player, probably the single most popular of the players today. How many of you use JW? Not surprising. There is a free version available for non-commercial uses. There is a reasonably priced version available for most other use cases. They support HTML5. The paid versions also include support for HLS and advertising and SDKs for other mobile devices as well. JW, very nice player, very customizable, very easy to use. Kaltura, how many of you use Kaltura's players? Exactly one of you. Interesting. Okay. Again, another open source solution. Theirs is under the AGPL3 license. And they have cloud-based players that are available for simple use cases. And in these simple use cases, you can provide any video asset you want to them. If you want to make use of it through their whole management system, they have embedded players that you can do a lot more with and just give it a token back to their server for how to play their files. They have support for HTML5 and Flash and iOS and Android. There's basic functionality for free and lots of additional features in their paid edition. Ooyala, any Ooyala users? Got one back here, okay. So Ooyala has HTML5, Flash, and mobile SDKs, a really nice ecosystem. Again, it's a fully managed system. This is not a player that you can use on its own. You only have to use it as part of their larger ecosystem. Support for all the main standards, RTMP, HDS, and HLS. They don't yet have Dash, but I would expect that to be coming in the not too distant future. And again, they support all the things that you would expect: video on demand, DVR, live, and they have, as part of their whole managed solution, lots of analytics and ad insertion and decisioning and all the things that you would expect. Again, very nice solution. And so let's just take a quick peek at some very simple use cases of each. So, for instance, we'll start with my mouse being turned off. There we go. Dash.js. So here we've got a real simple example of a Dash.js page. And so the main thing you'll notice is that we're including the source code for Dash.js. We've got a video tag on the page. And then basically we just get started. We tell it what our URL is. We create a context which basically has any of the variables, any of the specifics we want for how we're going to customize the player. We create a media player with that context, and then we tell the player to start up. We specify that it's going to attach itself to our video player here, and then we give it a URL, and it just runs. So taking a really quick peek at this. This is this one here. Let's hope my internet connection holds up for us. And so here is just a stripped down version of the Dash.js player running. And by the way, just in case you think there's any smoke and mirrors, it's exactly the same source code we were just looking at here. And so you have, again, a streaming content running through here. And if you take a look at our network, you can see the individual segments. Don't make a liar out of me. We should be seeing our individual segments coming in. They may be cached as maybe, there we go. Here's some segments starting to come in. And the whole idea, again, using the media source extensions, we're parsing the manifest, finding the files, and then handing one file at a time over to that video tag as we need it. All right, the JW player. Here's a simple example of JW being used. So again, we've got a script tag, and you're going to find a very similar pattern for most of these, where there is a library that we're going to include, some JavaScript code that's going to tell us how does this player work. So we include our JW library. We specify then a div, and the div is ultimately where that library is going to work. And then we write just a little bit of script to specify what we want to do. So we create an instance of the JW player and pass it a reference to that div, and then we call setup, and we can pass it different files that it wants to play. So we can tell, here's a Flash RTMP stream, or an HLS stream, or just a standalone MP4 file, and then some other properties. And of course, there's a lot more I could specify for it, but this gives us just a real simple example of JW working. The Kaltura sample, again, very simple. We start by including our script file. We get some configurations up and running. We create a div that's going to have our content. And then we basically, within script, pass through the proper references to get our player up and running. Video.js, another real simple example here. So once again, we're going to specify our script file. We're going to specify our video tag. And an interesting thing that Video.js did is they're following just the same way that you would work with HTML in any other way. You can specify child tags to your video tag to specify the sources. So in this case here, what they're showing is here are 5 different sources being specified. And based on how you want this content to look, what you want, if you wanted just a standalone MP4 file, or a WebM file, or OGV, or HLS, or Dash, any of the content can get specified, and you can specify multiple ones, and it will fail over from one to the next until it finds the one it knows how to play. Of course, in this particular example I'm showing you, I specified the progressive download MP4 first, so it will never try anything else. But that's neither here nor there. That was just a copy and pasting of the code. But that's how Video.js works, and it's, again, one of my favorites of these. Let's take a real quick. Oh, here's our Video.js example. Let's get this guy running again. And again, just pretty straightforward, simple player, and very customizable as well. So now, of course, the other side of the equation is, what if we want to just go ahead and build it ourselves? So we can do that. And again, there's been lots written about building players in Flash or in Silverlight. I can't imagine, does anyone have any intention of going out and building a Silverlight player today? Okay, let's just ignore that part. Flash, anyone looking to build custom Flash players today? We've built lots of custom Flash players. So there's a lot of good tools out there. Getting your head around Adobe's open source media framework is a really robust way to get started. It's going to take, if you haven't worked with OSMF before, it's going to take a little while to get your head around OSMF. Some of its architecture requires thinking differently than you may have previously thought about applications. But it's not bad, it's just confusing at first. I've now spent a lot of time in OSMF, and I'm very comfortable with it. Most of what I'm doing these days for building players from the ground up is using media source extensions. And so let's take a quick peek at what that might look like. So I've got so here, you'll notice I'm not including any code. We've got everything that we need to make this work just in one simple standalone file. So I'm just going to walk you through the fundamentals of how you build a media source extension player. Right, so ultimately, and again, this is a really stripped down player, which is the same fundamentals inside here as what you'll find inside Dash.js. So what I'm doing to get started, I'm hard coding values that if I were building a real Dash player, I would be reading these values from the manifest. But ultimately, just to give you as a sense of, without having to walk you through, here's the 18 different variations on a Dash manifest, let's just talk about how does the video player part of it work. Is that okay for everyone? I can go the other way if you'd rather. Okay, let's go here. So the media source extensions, in their interaction with the video tag, are going to want to understand what the MIME type is and what the codec is. So I've got just hard-coded values referencing the particular video content I'm playing. And so what we're going to do is, as we start up, we're going to create an instance of the media source class. This is where the name media source extensions come from. There's a media source class that is part of this standard. And I'm just going to declare some variables for a source buffer. In this particular content I'll be playing back here, I have the Dash manifest, I've read it, I know there are 65 segments, so I'm going to build it to simply start at segment number 0, and when it gets to segment 65, it's going to stop. So I'm just setting some variables for that up front. Again, in a real-world player, with Dash, you would read from the manifest. That content's all available to you in there. And again, if you want to see what the manifest for this exact content looks like, come talk to me over a beer. I'd be more than happy to walk you through exactly all of that. I've got the manifest as well. All right, so as the player starts up, we're just going to add a couple event listeners. We're going to listen for the source open, the media source to be opened, and the source close. We're going to get a reference to our video tag, and ultimately what that video tag is just literally an HTML5 video tag. And then I'm going to specify for the source of that video tag, I'm going to use the create object on that MS, which is my media source. So now effectively I'm creating a link between the media source extensions and the video tag, so that as I interact with the media source extensions and I hand them content, the video tag will know how to work with those and get the content. So opened is what happens when my media source is open. So I'm going to first of all tell the source buffer, which you can guess from the name is the buffer for where we put the content, what the what the codecs and the MIME type are. So those variables I set up top, here and here, I build into a string in the way that the media source extension specification tells me I have to. And I specified I'm going to create a source buffer with that value. And then what I'm doing, are most of you guys comfortable with JavaScript? Some of you comfortable with anyone comfortable with JavaScript? Let's pretend we're comfortable with JavaScript. We're going to use the JavaScript method for how we make HTTP calls from JavaScript. We'll make an XML HTTP request, which is a misnomer anyways, because we use it for things that aren't just XML anymore, but that's neither here nor there. So basically, we're making an HTTP request. We create the request. We tell it what to expect. As the content comes back, what is it? It's going to be a buffer, an array of buffer in it. And so then I'm going to specify the URL for the header, for the initialization segment, which contains all the information that the video tag will need to get started. It'll figure out the size of the video from this and other elements of that sort. So I make a GET request, and as I have my onload, as it's done loading, I'm going to go ahead and just append that data into my source buffer. As it's adding that, it takes a certain amount of time for that append to happen, and by a certain amount of time I mean microseconds, but it's an asynchronous operation, so I need to listen for it to be done updating before I start to load more content. So I'm listening for the update end event, and when that happens, I call load segment. So, and basically the fundamentals are, well, as you're working with this, you need to first prime the pump. You need to tell the video tag, here's the kind of content you're playing. And that's what that header segment is all about. It has all of the binary data from the first 150 bytes of the MP4 that tells that the video tag will use to know how do I play it. And so once we've got it all set up, we're then going to just call load segment. And what load segment will do is basically, I know how many segments I have, so I'm going to see if I'm not yet on the last segment, I'm going to tell it to go and get whatever number segment I'm on now, and then I'll increment that number. So as I go to get a segment, once again, I'm going to build an XML HTTP request. And this is where I'm actually building out, again, this particular real stripped down example, there's no adaptive bit rate to it. Dash.js has lots more logic to it, and it's not just in one file for obvious reasons. So I'm just hard coding that I want the second adaptation set. And I was sort of guessing based on what the bandwidth in this room might be. I'm hoping that the second adaptation set works well for us. If it stutters, I probably should come back and change this to the third adaptation set or the fourth. But that's what there's a directory, video 1, video 2, video 3, video 4, video 5, where 1 is the highest quality, 5 is the lowest quality. And the way this particular stream is set up, each individual segment just has a number. So there's 0, 1, 2, 3, 4, 5, all the way up to 65 for this particular stream. So I'm going to build the URL, append in the segment number, and then the extension .m4s. And so as it's done loading that, I'm going to read the content, append it into the buffer. And so that is fundamentally how this works. So it's going to load each piece of content. Again, we've already added on the source buffer this update end. So as each one is done getting added to the buffer, it's going to once again call load segment, and this time the segment number will be 1 higher. So it's going to keep incrementing until it's loaded all the content for us. So if we take a quick peek, I've got DIY here, the do-it-yourself player. So here, we've got the content, and let's start this once again. Right-click, empty cache, and hard reload. Let's see some segments come in on this network. All right, so you'll start to see here the various. So first I loaded my header M4S, then 0 M4S, 1 M4S, 2 M4S. It may be quality may be slightly too high for us in the bandwidth that I have available to us today, but you can start to see exactly how this is working. All right. Does that make sense? Does that give you at least a primer for how to build the players with media source extensions?
Question for you.
Yeah.
In this case, I realize there's probably more control over how this works. So when you're downloading, you download the initialization segment, and then the first segment that actually has content to it.
Right.
As far as at least this example here, at what point do you actually start playing the content? Or how much buffering is there actually?
Excellent question. So the question is, we can see that we're downloading the header and then individual segments after it. how much content is it going to download before it starts, how much is it going to buffer before it starts to play back. And in this particular case, I haven't set the minimum buffer time. So I believe it's going to wait for one full segment to be in the buffer, I believe is the default for Chrome's media source extensions. I could look that up and find out specifically, but there are controls that you can use to determine how much or how little you want in the buffer. And there's been lots of work on, within the Dash.js project, which I'm most familiar with, strategies around fast startup, but trying to keep this playback as smooth as possible. So we try to start with as small a buffer as possible to get playback starting quickly, but then grow the buffer over time. And there's far more nuance to that than I could possibly cover. But it's an excellent question, though. All right, so that gives you at least, again, a sense of the, a number of the more popular off-the-shelf players, how they work, how you can start working with them. And again, I could very easily give an hour on each of those 6 players and their specific nuance, given I'm trying to cover those 6 and building it yourself in 45 minutes. We've just sort of scratched the surface, but feel free to pull me aside and ask questions. I'll be happy to go into any more detail as you like, especially over a beer, which starts in 20 minutes. All right, so finding the right fit. As you know, there's lots of different factors to consider, right? Are you looking for something like Ooyala, which is a fully managed service? Are you looking for just a standalone player? Are you looking for something that is cheaper and less functional, or something like Adobe Primetime, which is not cheap at all, but provides tons and tons of functionality? There are lots of choices, and it's based on what your particular needs are. Some people need the quick, dirty, cheap, make it work. Others need I've got 18 channels of high-definition television, and I want to make sure that they're properly monetized and properly measured and all of that. There's a wide variety of choices. Dash.js, which I've spent the most time on myself, it's a very narrow focus. It doesn't try to do everything for everyone. It tries to play back Dash in a browser. It has no concern beyond that. It doesn't care about HLS. It doesn't care about Flash or Silverlight. It doesn't care about iOS because iOS doesn't care about media source extensions. So it's but what's interesting with Dash.js, of course, is that it's been adopted by several of these other players as their Dash solution. So while it's a narrow focus, it fits in nicely into a larger focused player. So it's all a matter of finding the right fit for you. And I, of course, can't tell you, you must use Brightcove. You, Kaltura. Over you, Ooyala. I can't tell you that. Well, I just did, but I was lying. It's just a matter of figuring out what you need. Where do you want to deploy it? Are you looking purely for a web-based solution? Are you looking for a solution that has SDKs, or you want to have the same provider working for you across all of your devices? What does all of your devices mean? Is it just phones, tablets, and desktops? Are they set-top boxes? Are they over-the-top boxes? There's a large variety of variables that you first want to make sure you understand what you need. You want to understand what formats do you want to support? What codecs do you have your content in? If you're starting from the ground up and you don't have content yet, you can do anything you want, right? You can choose your codecs. Yes.
I never heard you mention anything about captions.
Oh, excellent. So the question is about closed captioning. And the reality is that every one of these solutions I've mentioned today, they all have APIs for enabling closed captioning. They all handle the closed captioning slightly differently. Primetime handles them as per the 608, 708 specification, so it's looking for the captions to be in band, although with not too much work you can use sidecar captions just as well. Video.js is built around the idea of WebVTT sidecar captions, although with a little bit of work you can use in-band captions as well. They all have captioning solutions. But so basically, features like captioning, where do you have your captions stored? Are they in band within the binary? Are they in external files? Are you looking primarily for video on demand solutions, or are you looking for live? Folks who haven't built video players often don't realize how vastly different those two use cases really are. Most folks, well, it's video. What does it matter? It's live, it's on demand. It's the same thing. It's not. It's really, really different. Sir.
Can you talk a little bit about protecting
Okay, so question in the back of the room about adaptive bitrate logic and how do we determine what bit rates should be used? How do I know which rendition to play to an end user? And this is, of course, an hour is not anywhere near enough to cover this topic in the depth it deserves. We've actually built a number of different ABR algorithms for different clients over the years. And there are so many vastly different use cases. When we're doing a lot of work in live sports, we tend to err on the side of lower quality but lower latency. So we want to get content to people as quickly as possible with as little buffering as possible. When we're doing work with art galleries and museums, they don't mind if there's a little bit more buffering, so long as people see it in the highest possible quality. And there's billions of variations in between. But there's a number of different metrics that we're constantly monitoring to try to figure out what bit rate is appropriate. And oddly enough, bandwidth it's an important one, but it's not the be all and end all. When I first wrote Dash.js, my ABR algorithm was based on nothing but what can I calculate your bandwidth to be? And it didn't work very well at all. It was not effective because it ignores all the internal environmental variables of your computer. So if your computer is dropping a lot of frames, if your computer is stuttering a lot, you may have all the bandwidth in the world, but your processor may be taxed. And so there's lots of different variations, and feel free to, again, up on GitHub, the Dash.js project, dig in. You can see all the crazy stuff that we're doing to try to come up with a comprehensive set of rules, and there's always more. As we're a consulting company, as I build Dash.js players for my actual customers, the thing I change most often are our ABR algorithms to fit their particular use cases. All right. So in summary, there's never been more good choices available. There are tons and tons of great choices out there on video technology. This is a blessing and a curse. Right? When there's only one choice, life is easy. When there's a million good choices, it's all a lot harder because you don't know which one to choose. Hopefully I've given you a little bit of information about not all of, but many of the options available to you. There's lots of valid choices off the shelf. There are also still valid times. I still have a number of customers that I'm still building from the ground up custom video solutions because none of the off-the-shelf ones are customizable enough for their specific needs. In truth, we're doing a lot less custom player development this year than we were in years past. The off-the-shelf players, they're catching up. They're figuring out how to, what level of customization real-world customers need. And they're starting to fill that gap. So we're doing a lot less of the customization, of the custom development, and a lot more of integrating other players. Which, any of you that were at my session last year I was really talking about building players from the ground up. This year I'm talking much more about you can also integrate all these other great players that are out there, which is directly mirroring where my business is. And again, be aware of where do you need to be? Do you need to be web? Do you need to be mobile? Do you need to be over the top? Do you need to be a set-top box? Do you need to be somewhere else? There's lots and lots of choices. Questions?
How about in an enterprise environment where browsers are standardized, we need the multicast? Is ground up really the only solution, or?
So the question is, in enterprise deployments where there are standardization across browsers and there's probably lots of security restrictions and other things, is building from the ground up the only option? The answer is no, actually. Kaltura focuses on the enterprise market. They do an excellent job there. And one of the things that you can often leverage multicasting and other features of the enterprise network that you don't have in other networks. So there's lots that you can do off the shelf in enterprise. We build less custom players for enterprise than we do for public providers. So.
In 2015, what percentage of your business has been MSE, AD versus RDMP,
I can only guess because I'm not the one that sends the invoices out at the end of the month. I'm the one that comes to conferences like this and talks to you guys. But I would guess that we are probably, this year, we've probably about 20% of our video work, and again, this includes new development as well as maintaining existing applications, which we do a lot of. We wrote players 10 years ago that we're still maintaining. So 15-20% of the new player development is MSE EME for us. Any other questions?
I have a bunch of questions. What version of Dash are you supporting in Dash.js? Is it Dash 2.0?
So the current the most recent release of Dash.js was Dash.js 1.3 that came out a month and a half, 2 months ago, and I believe that fully supports 1.0 and partially supports 2.0.
And you said that Video.js actually incorporates Dash to support.
It uses Dash.js for their Dash support, and several of the others I mentioned also.
Have they forked that, or are they just using it straight off of it?
So they've created a fork, and they are leveraging, because there were some incompatibilities between Video.js and Dash.js. Dash.js was built around a dependency injection framework. Video.js is not. And so largely what they've done is they've forked it, and they've basically lifted out the pieces of it that made most sense for them. So they're not using our adaptive bitrate algorithms at all. They already have all of those built for themselves. But all of our manifest parsing and our segment decisioning and all of that is coming from Dash.js into Video.js.
So if somebody wanted to implement like Dash 2.0 extensions, that would be done in Video.js?
So, well, ideally, I would love to see that done in the Dash.js project. And again, the Dash.js is starting to support that. The 1.4 release of Dash.js is scheduled for, I think, about 3 weeks from now. And there's a lot more 2.0 support in that. In the back.
What player do you think pretty much covers most of the popular devices out there?
So of the off-the-shelf, I'm just repeating for the camera. Of the off-the-shelf players, the question was, of the ones I've talked about, which one is going to support the widest number of devices? And without a doubt, Primetime has that one hands down. Primetime has SDKs for many, many things. That's after that. Most of them have Android and iOS SDKs, so they're pretty equal footing on that. I think Ooyala might have a few of the set-top boxes, but and a JW Player already has native support for Chromecast, which is pretty trivial to build into any application anyways. It's a pretty even playing field once you get past Primetime. Other questions? All right, guys. Well, thank you very much.